Good morning, guys. Welcome to the Academy tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please do press subscribe button and notification bell. And also our update on this YouTube channel. Thanks once again, and God bless you. Today I will be considering what NECO 2022 Physics Practical under the branch known as what electricity. Now, this year we are provided with what with a metal bridge, standard resistor of X, galvanometer, jockey, battery, a key, resistor box, 1 ohm resistor, and some connecting wires. You can see the meter bridge is here. The standard resistor of 2 ohm labeled what X. It's labeled X here. Standard resistor labeled X. Now the galvanometer, the jockey, we have the jockey here. We have the battery, the key, the resistance of box, 1 ohm resistor, this 1 ohm resistor here, and then some connecting wires. Now connect the circuit as shown above. Now this is the circuit diagram that you see in your exam. This is the circuit diagram that you see in your exam. But if you want to connect it to make things easier, this is how you should This is how I interpret it. Now this is what you are going to see in your exam, but this is how I interpret it. Now this is it. Now well, having what point A, which is connected to the positive end of the battery here. This is the point A connected to the positive end of the battery. You can see the wire here is red now connected to the positive end of the battery. Now that shows that the A is connected to the positive end of the battery, and the B is connected to the which is the negative, is connected to the key. This is our key here. Now that is and the key has a wire that goes directly to the negative end of the pole. Now this is the A is connected to the positive end of the battery, while key is connected to the negative end of the battery, which goes to the point B. Now that's that one. Now from the point B, now we have standard ohm resistor labeled X, which is 2 ohm. Now it's connected with the 2 terminal that we have at the right hand side of the meter bridge. Now the standard resistor is connected with the 2 terminal that we have at the right hand side. This is it. And we have we have the resistor box here. Look at, before we get to the resistor box, we have our galvanometer. The galvanometer, the positive end of the galvanometer is connected to the positive end of the terminal in the middle of the meter bridge. Now, of the terminal in the middle of the meter bridge. And so the positive end of the galvanometer goes to the positive terminal, which is at the middle point of the meter bridge. So that's what we have here. You can see the connection here. Now, and the jockey is connected to the negative end of the galvanometer. Now the resistor box now is connected to the extreme terminal, the extreme 2 terminal on the left hand side of the meter bridge. Now, so we are connected the resistor box to this, and also connect the standard ohm resistor of 1 ohm, standard 1 ohm resistor. The 1 ohm resistor given to us, which is 1 ohm, I connected it to this terminal as well. So that's why we have this and this in parallel. Then we have this one here at the extreme end. We have the galvanometer, we have the key, and the battery. So that's about the setting up of the circuit. Now, having connect the circuit as shown above with resistance box state 10 ohm, obtain a balance point J on AB. We have to obtain a balance point J after setting our resistance box to 10 ohm, which I'm going to do now. This is the 10 ohm resistor. I will remove it. Now, we should now obtain a balance point of J on AB. Measure and record AJ. I will be measuring AJ. That is from the point of A to a balance point is our AJ, which is known as L. Evaluate L inverse and R inverse. Repeat the procedure with the values of R equal to 20 ohm, 30 ohm, 40 ohm, 50 ohm, and 60 ohm. Now, This is just one of the way of setting the questions. Now let's do this. Now we have what? We have the serial number. We have the serial number, which is what? Which is 1, 2, 3, 4, 5. Now let's see whether it's up to 6. We have 10, 20, 30, 40, 50, 60. So it's up to what? 6. So this is 6 value. So we have the another column, which is what? Our R. The unit is what? Per ohm. We have our air, which is centimeter. Now we have to evaluate what? L inverse, which is per centimeter. But first of all, before that, we can be asked to calculate 100 minus what? L. So 100 minus L first, then let's introduce another column, which is what? L inverse, then R inverse. This is per centimeter. This is per centimeter, which is L inverse. This is what? Per ohm. So that's that about that. So now we have to evaluate all these things. Now, to go about this now, how do we go about this? We have to set the first one is what? 10 ohm. The 10 ohm resistor. The second one is 20 ohm resistor. The third one is what? 30 ohm resistor. The fourth one is 40 ohm resistor. The fifth one is what? 50 ohm resistor. The other one is what? The last one, which is what? 60 ohm resistor. Let's demarcate it for what? Easy identification. So now I've set what? The resistor box to what? To 10 ohms now. Now I will close my key here, ensuring that all your battery is intact. Now close the key, take your jockey, then let's read. And you can see the deflection now. So this is what? This is 56.5. And you see where I have my what? Deflection to be 0 now. I'll read the what? The point or what? This is where I have my what? You have to be careful to have the what? 0 what? So now I have set what? I have set the what? My resistor box to what? 10 ohm. Now I will ensure that what? Everything is intact. Now I'll plug in my battery. Now let me what? Let me insert the key now and read the what? The reading on the what? You can see there's a deflection. Now you begin to move from that end now. From that end. So I've gotten to my what? 0 point. Where the galvanometer is what? 0. I want you to see, that's why I put the direction of galvanometer to the camera here. Because I want you to see where the G is equal to what? 0. So at this point where G is equal to 0, you take your value of J. Now your J here is what? Is 56. Is what? Is 56.50. Is 56.50. We have 56.50 here as our J. So now our hand here from this point to this is 56. So I'm going to record what? 56.50. So that's my head for the first value. For the first value, which is 10 ohms. So I will remove my key now and plug in 20 ohms. So you take away this, you plug in the 10 ohm back and remove your 20 ohm key. Now, also now, plug in your key. Plug in your key. And sure everything is alright now. Let's place this gently. You're reading, you can see the deflection. You can see the deflection. So this is what our zero deflection now. So this is 58. We have 58 here. From this point now to this place is what? 58. Please take note of that. 58. So we have 58.00. So now 58.00. So the next thing is what? Is to carry out the what? Others now, which is set this to 30 ohms. Now remove the 10 ohm. So make it 10, 20 plus 10. 20 plus 10. We give it 30. So this is 30. Plug in your key. Then place it again. See, there is a deflection, so you begin to what? Make sure that you don't touch other aspect of the ruler. Only the what? So this is 60. This is 60. Exactly what? 60. So we have 60 here. We have 60. 60.00. So we have 60.00. Now the next one is 40. Return the 10 ohm key. Then remove another 20. 20 plus 20 will give you 40. Close your key now. And place your what? Your jockey again. You can see the deflection. Start to move. Okay, this is 62.80. 62.80. Now we have 62 point what? 62.80. 62.80. Now we got the 40 ohm, which is 62.80. Let's go to 50 ohm. Now to go to 50 ohm, you return the 20 ohm resistor now and remove the what? 50. Now if you remove the 50 now, then you close the what? Key here. Place your what? Jockey again. Ensure that they are tightly what? Placed. There's a deflection already. So now let's get our 0 watt deflection. So this is 60, this is 65, this is 65. Okay, this is 65 here. So 65.00, and the last one here is 60. So this 50 already, we remove one. Then plug in your key. So here I'm going to place it our jockey now. You begin to move. Okay. Backward. We have what? 69. 69. This 69. We have 69.00. Now, I haven't gotten the value of radius now. Let's go into our evaluation. Table of value now. Let's evaluate L inverse and R inverse, and then 100 minus L. So 100 minus L here. Although we are not asked to calculate 100 minus L, but it's on. I indicate that what I include it in what the diagram. So 100 minus L will be what? 100 minus L will be 100 minus 56.50. We have what? Here we have 43.50. We have 100 minus 58 to give you 42.00. This one will give you 40.00. This one will give you 100 minus 62.80. We have 37.20. Now 7.20, we have what? This one will be 35.00, and this one will be 100 minus 69.00. So we have 31.00 here. So now, with this now, let's find what? L inverse. 1 divided by 56.50. We have 0.0176 to 4 decimal place. So 1 divided by 58, 0.0172. 1 divided by 60, 0.0166 to 4 decimal place. 1 divided by 62.8, 0.15, 0.0159. So 1 divided by 65, 0.0153. 1 divided by 69, 0.0144. So that's to 2, 3. This is to 4 decimal place, so that we can easily get a plotted value here, because if we have to approximate this one to 3 decimal place, we won't be able to plot our graph very well. So our graph might not be accurate. So that's why you should maintain 4 decimal place. Later we approximate it to 3 decimal place when plotting the graph. So our inverse will be 1 divided by 10, 0.100 to 3 decimal place. 1 divided by 20, 0.050. 1 divided by 30, 0.033. So the next 1 divided by 40, 0.025. 0.025. Then 1 divided by 50, 0.02. 1 divided by 60, we have 0.01, 0.016, 0.016. So to 2 decimal place now. Okay, we are doing it to 3 decimal place. You can see this 3 decimal, 3 decimal, 3 decimal, 0.016. So these are the value. 1 divided by 10 is 0.1, 1 divided by 20, 0.05, and so on and so forth. So this is the table of value now. After written out our table of values and carry out the evaluations now, what are the next thing to do? Now we are asked to plot a graph with L inverse on the vertical axis and R inverse on the horizontal axis. We have to plot a graph of L inverse against R inverse. Now, to plot a graph of L inverse and R inverse, the first thing to do is to write out your the value that you wanted to plot. So I'm writing it here now. I'm having the L inverse on the vertical axis, which is per centimeter, and O inverse, that is restant inverse. So we have 1, 2, 3, 4, 5, then 6. So now look at the value of L inverse. Now the highest value here is is 0.0176, and we can easily approximate to 3 decimal place, because these are 111. It will be difficult to approximate to 2 decimal. If we approximate to 2 decimal place, to plot it on the graph, the point will be on the same spot. So that's why I have to approximate it to 3 decimal place. So this is going to be 0.018. 6 to 7, 0.018. 2 to 7 is nothing. There is nothing. So you have 0.017. Because this one is not up to 5, so you will neglect the 2. So 6 is more than 5. So you add it to this one, you add 1 to this one, you have 0.017. This one now we add 0.015, add it to this 0.016. Now for that, the fourth one 0.016. For this one 0.017, 0.016, 0.015. So you can see that this is not up to 5, so 0.015. This one is 0.014. So with this now, we have successfully approximated this L inverse. Now this one we have what? We can just use this one directly. Since we can locate what? This one is 0.12. Write that one as 0.10, 0.050, 0.033, 0.025. This one I'm not appropriating this one is because to be able to have a graph that is very, very what? Accurate. So 0.016. So now let's quickly what? Draw the graph now of F inverse against what? Of F inverse against so now we have what? Graph of let me quickly clean this one. We have graph of L inverse, which is per centimeter, against R inverse, which is per ohm. So now, I will write this one. Now, the first thing that should come to your mind is my scale. How will I choose my scale? Well, 0.018 as the highest value and 0.014 as the what? Lowest value here. So if you think of what? Using 0.002 times 10, this one will definitely 0.002 times 10 will give you 0.02. So and this one is 0.018. So it's very close to 0.02. So now, and we have, if we count from here now, you are going to have what? 10 boxes on the vertical axis. Like for example, now 1, 2, 3, 4. Okay, 2 centimeter box. I'm talking about 2 centimeter box. 1 from here to here is 1, from here to here is 2, from here to here is 3, 4, 5, 6, 7, 8, 9, 10. You can see now. So it's better we start from here. So we use 2 centimeter what? 2 centimeter represents what? 0.002. 0.002 per centimeter on L inverse axis. Now we have 2 centimeter represents what? Now look at this one is 0.1. We can easily use 0.001. 0.01, that is per ohm, because on R inverse axis per ohm on 1 inverse axis. So 0.01 per ohm on R inverse axis. So with that now, let's quickly what? Do this now. We have what? We're starting from here. These are our 0 points. So it's going to be what? Don't forget this is going to be 0.002. 0.004, 0.006, 0.008, 0.010, 0.012, 0.014, 0.016, 0.018, then 0.020. So that's that. You can see. So now this one now will be our this one will be our 0.0. So this one will be 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, 0.10. So that's that. Now, can even add what? 0 to it. So we are using this decimal point so as to be able to read it very well. So that's that. Now, we have L inverse per centimeter inverse, R inverse per ohm inverse. So let me take my ruler now and rule this vertical line here. So now, with this now, let's locate our graph. Now, the first point here is what? 0.018 against what? 0.01. 0.018 against 0.1. 0.1 against 0.018. So your first point here is here. So the first point is what? Is here. First point is here. The second point is 0.017. 0.017 will be the middle point of this because it's 0.016. 0.017 is here against 0.017 against 0.05. Now 0.017 against 0.05. So you trace this to this 0.05. Trace it to this point. Now we have another point here. So we have another point here. So now the next one is 0.017 again, 0.033. Now look at it, 0.030. So this one will be 0.031, 0.032, 0.033. So this point here is 0.033. Don't forget that this is 0.03. This line is 0.03. So 0.031, 0.032, 0.033. So from here now 0.033, you trace it up against what? 0.17 against the same place. So as this, so we just now 0.016 against 0.25. 0.016 here against what? 0.25. 25 will be between 0.02. So we have 0.25 here. 0.025 here. So now, with this now, we have 0.015 now against 0.02. 0.015 will be here against 0.02. So we have another point here. So 0.015 against 0.02. So then the next one, 0.014. 0.014 against 0.016. 0.01, 0.01, 0.015, 0.016 is here. Please, you have to 0.016 against what? 4. We have what? So now look at it very well. We have what? 0.016 here against 0.014. So that's that. So if I want to choose points here now, I'll go for. So let's just take this one. This it takes 3 points. Now we have so it takes 3 points now. It's not a bad thing. So that's that about that. These 3 points and this one at our outliers, that is they are even not far from what is the outliers. So you can also be intercept. Let's just calculate the slope now. Let's see what we have. So now I have a point here. So now we have another last one here. So now so this is your angularity. Now let's put our value. This is 0.010. This is 0.012. So now let's quickly calculate the slope. So what is the slope? Now this slope will be what? Slope S now will be changed in change in L inverse per centimeter all over change in R inverse. So now X now, what is our what? Change in L inverse. This is L inverse what? We have what? This is our L inverse. So this is our L inverse what? L inverse 2. L inverse 2. This one is L inverse 1. L inverse 1. L inverse 1. So with that now, let's write it out. L inverse 2 minus L inverse 1 all over R inverse 2 minus R inverse 1. So it's equal to, now we have what? Look at this, we have this is 0.019. 0.019 to 194, 196. This one got 0.0196 because this is 246. So minus that of this one, 0.010. So I've got 0.010, so I'll be 0.011. 0.011. 24 to add 0, that's 0, we can add it to it. Now, don't forget this is per centimeter. So we are still going to put it later. This is per centimeter and this is per what? Per ohm. Per ohm. So with this now we have what? We have what? We have 0.0196 minus 0.0110. For R2 inverse, and this one is R inverse 1. So this one is 0.040 minus this one is what? 0.001, 0.002, 0.003. So this one is 0.003, so 0.004. So it will be 0.00. Now look at it very well. It's going to be 0.004. So that's it. This is 0.001, 0.002, 0.003, 0.004, 0.005, 0.006, 0.007, 0.008, 0.009, 0.01. So that's it. So when you minus this one, what do you get? 0.0196 minus 0.0110. Now, here we have 8.6 times 10 square minus what? 3 power per centimeter all over 0.040 minus 0.004. 3.6 times 10 square minus 2. So if you cannot do it like this, use calculator directly because this calculator brings standard form. That's why I'm doing that. So 1, 2. So now you divide this one now. Just use what? This one means what? If you take this one to the other side, it also means what? 1, 2, 3. It means 0.0086. 1, 2, 3. So that's what it means all over 0.03612. So don't commit yourself with it. You cannot use the standard form, use normal words. So this is per whole. So that's why I express it like this. So we have what? 0.0086 divided by 0.036. The answer here is 0.230 ohm per centimeter. So that's that about that. How gotten your slope now? The next question is take 2 precautions in obtaining this one. So the first thing is that I avoid error due to parallels when taking reading on the meter bridge and the galvanometer. I also ensure that the key is open when the circuit is not used. So ensure that the key is open when the circuit is not used. So now that's that about that. So I've come to the end of today's class. Please, if you haven't subscribed, please do the subscribe button and notification bell. That's our update on this YouTube channel. Thank you and God bless you.